Do you know about the basic principle behind the existence of homogenized milk? Have you ever imagined the existence of blood, paint, ink, and ceramic and cement slurry? Double layer or electrical double layer. Double layer. In surface science, a double layer DL, also called an electrical double layer EDL, is a structure that appears on the surface of an object when it is exposed to a fluid. The object might be solid particle, gas bubble, a liquid droplet, or a porous body. The double layer refers to two parallel layers of charge surrounding the object. The first layer is the surface charge, consists of ions which are absorbed into the object due to the chemical interactions. And the second layer is the ions attracted to the surface charge via Coulomb's force, electrically screening the first layer. This second layer is loosely associated with the object. It is made of free ions that move in the fluid under the influence of electric attraction and thermal motion. The scale of this layer is about micrometers to nanometer. The double layer important to phenomena such as electrochemical behavior of electrodes. Homogenized milk exists only because fats droplets are covered with double layer that prevents their coagulation into butter. Double layer exists in practically all heterogeneous fluid based systems such as blood, paint, ink, and ceramic and cement slurry. It also important in the case of electrokinetic phenomena and electroacoustic phenomena. The latest studies shows that ultra-fast laser reveals how electrical double layers form in trillionth of a second. Electric double layer are invisible electrical interfaces that are of great importance. They regulate how energy is stored in batteries and capacitors, how cells communicate in the human's body, and how water involves through the soil and membranes. Studying electrical double layer using light. When a negatively charged surface of a metal electrode comes in contact with the liquid, it begins to attract positively charged ions from the surrounding liquid, forming a thin compact layer right next to it. This buildup of positive charge creates an imbalance, triggering the formation of a second layer of negatively charged ions just behind the first to neutralize the system. This combination of two closely packed layers of opposite charges, one on the surface and one in the liquid, is known as electrical double layer. The conventional electric measurement tools lack the temporal resolution required to capture electric double layer. The researchers employed a unique light-based approach. They began by adding acid to water, which causes positive ions H3O+ to form. These ions perfectly arrange themselves at water surface where they form electrical double layer. A strong laser pulse in the infrared range was used to heat the surface, removing H3O from the surface, thereby perturbing the double layer. By investigating the surface with the further laser pulses after a time delay and detecting the reflected light, they were able to quantify how the ions moved away from the surface to reach a new equilibrium. They combined their experimental results with computer simulations. This enabled them to prove that the formation of the double layer is primarily caused by electric fields even at high concentrations.